Hi guys, for today's video, we will discuss resistors in parallel circuits. Let's consider this given circuit. First we have to calculate the current flowing in each of the resistors. We labeled the current flowing in each of the resistors as I1 and I2. I1 will be equal to Vt over R1. So as we use the values, it is equal to 30 divided by 6, which is equal to 5 amperes. I2 is equal to Vt over R2. It is equal to 30 over 10. This will result in 3 amperes. The total current labeled as IT. Applying Kirchhoff's current law, all the current entering the junction is equal to the current leaving the junction. So IT is equal to I1 plus I2. Plugging in the values, 5 plus 3. It's gonna be 8 amperes. But you can also solve IT by voltage source Vt divided by total resistance, RT. Later, I'll show you how to solve this. Next, is to solve how much power is absorbed by each of the resistors, labeled as P1 and P2. Power can be solved by multiplying V times I squared times R, or V squared over R. So for P1, we will use Vt times I1. In a parallel circuit, voltage source is equal to the voltage across each of the resistors. So Vt is equal to V1 and V2. P1 is equal to 30 times 5. It will result in 150 watts. Then for P2, I will use I squared times R. Using values, 3 squared over 10. It's gonna be 90 watts. Okay, now how much power is delivered by the source? Pt is equal to Vt times It. So 30 multiplied by 8. It is equal to 240 watts. Adding P1 and P2, it will be equal to 240 watts, which is also equal to total power delivered. Meaning our computation on power absorbed and delivered are correct. Lastly, is the total resistance, which is equal to the product over the sum of two parallel resistors. R1 multiplied by R2 all over R1 plus R2. RT is equal to the product of 6 and 10 all over 6 plus 10. It will be 60 over 16. And the answer is 3.75 ohms. And to show you how to solve total current IT using total voltage and total resistance. It is equal to Vt divided by RT. 30 divided by 3.75. This will also result in 8 amperes. Another example guys, as this circuit consists of 3 resistors. First, we have to find the current flowing to each of the resistors. Let's start with I1, which is equal to Vt divided by R1. 60/10. This will give us 6 amperes. Then for I2, which is Vt over R2. Plugging in the values, 60/12. This will result in 5 amperes. And lastly for I3, which is Vt over R3. 60/14. Then it is equal to 4.29 amperes. By the way guys, at this junction, the current here is the summation of I2 and I3, since they are both leaving the junction. And this will be 9.29 amperes. And also in this junction, it is also equal to 9.29 amperes, because the two currents I2 and I3 will enter here. At this point it will be equal to the total current, because as you can see the 9.29 amperes and I1 both leave the junction. Same with this point because 9.29 amperes and I1 both enter this junction. Now to solve for its total current. We will add all the current flowing in each of the resistors, I1 plus I2 plus I3. 6 plus 5 plus 4.29. So the answer is 15.29 amperes. Next, we are going to solve for the power absorbed by each of the resistors. Again, power is equal to V times I. So P1 is equal to Vt times I1. Substituting the values, 60 times 6. This will be 360 watts. For P2, 60 times 5. And this is 300 watts. For P3, 60 times 4.29. The result is 257.4 watts. So next, we will solve the power delivered by the source. It is equal to Vt times It. Using the values, 60 times 15.29. The result is 917.4 watts. Then we will add P1, P2 and P3. 360 plus 300 plus 257.4. This will be equal to 917.4 watts, which is also equal to the total power delivered by the source. Next, is to solve the total resistance. The formula of the total resistance of the three parallel resistors is equal to 1 over R1, plus 1 over R2, plus 1 over R3, raised to -1. Plugging in the values, 1 over 10, plus 1 over 12, plus 1 over 14, raised to -1. This will be simplified to 107 over 420, raised to -1. To remove the negative exponent, then it will be 420 over 107. Or it can be simplified to 3.93 ohms. So that's it guys, that's how we solve parallel circuits. Thanks for watching. If you enjoyed this video on parallel circuits, hit the like button, subscribe, and stay tuned for more. Questions or comments? Drop them below. See you next time.